Okay, right, the Big Bang. Really quick run through the Big Bang. So, first of all, cosmological principles. So, the universe today, it's homogeneous. Homogeneous means that every part of it's the same as every other part. So it's homogeneous. It's also isotropic. Now, what that means is it looks the same in every direction. And the laws of physics are universal. They operate all through the universe. So the stuff what we know about the solar system, we can apply to the rest of the universe, okay? Now, the Big Bang Theory is about how the universe started off. So to start with, we think that it was a very hot, very dense, possibly infinitely hot and infinitely dense singularity. Okay, so it was just a point, and everything was within that point, and that's why it was extremely dense and extremely hot. Okay, now since the Big Bang, this point has been expanding ever since. Okay, so Big Bang happened, and then the next bit, the first bit that you need to know is that the forces that we know and that we use sort of came into play very, very early on. So less than a second, we've got the four main forces. So we've got gravity, we've got electromagnetic forces, we've got a strong force, and we've got the nuclear strong force and the nuclear weak force. So these are sort of the first things that sort of started to exist. Now, all the stuff, all the matter to start with was in quarks and antiquarks and leptons. And there was also quite a few photons kicking about. Okay, so nothing had sort of joined together yet. Everything was sort of in fundamental particles or packets of energy. Okay, so it's like a sea of quarks, antiquarks, leptons, and photons. Now, the next thing that happened is that the quarks formed protons and neutrons, okay, and also antiprotons and antineutrons. So the protons and neutrons, they were formed next. Now, what happened at this stage was that we've got this matter, also antimatter was formed, and what happened was that some of the matter annihilated, and I never spell that, annihilate, some antimatter. Okay, now we've looked at this happening before. We've looked at electrons and positrons annihilating when we did about PET scans. And what was produced then was two photons, and those photons happen to be in the gamma range. Okay, because if you remember, the way that we sorted out what sort of photons we'd get was we looked at E equals mc squared, and if we had the annihilation of the mass of electrons and protons, it had to be that the energy produced would be in the, if we put that equal to HF, that would be in the frequency of gamma. So we've got some gamma photons that are produced at this stage. Now, these are the photons that are going to become the cosmic background radiation, or that are the cosmic background radiation, that I'll talk about in just a bit. Okay? Now, the next thing that happened after the protons and neutrons formed. Now, we're only looking at 100 seconds after the Big Bang now. So all this had happened, really, really, really quickly. 100 seconds after the Big Bang, what happens is the protons are cool enough to be able to sort of do nuclear fusion, and we start forming helium nuclei. Okay, so the H there, the hydrogen, that manages to fuse, and we get some helium nuclei. Okay, now we only get the nuclei, we don't get the atoms. Atoms don't happen till much, much later. So what we're looking at later is 300,000 years later. Okay, so this has all happened within a second, this has all happened with 100 seconds. then we're looking at 300,000 years. Now, the universe is cooling all along this time. So after 300,000 years, we've got electrons managing to combine with protons and neutrons and form atoms. Okay, combine with protons and neutrons, and what you get is you get atoms. So no atoms as such formed within all of this time. When we're around this time, it's like the whole universe was like a star in its main sequence, because that was all happening. We only had nuclei. It was all sort of plasmary. So atoms only formed after this time here. Okay, now it's relatively the same, but we've cooled to 2.7 Kelvin. Okay, so that's taking you through what happened just after the Big Bang. Now, you've got to be able to say what your evidence is for the Big Bang. Okay, and you've got two forms of evidence. You've got the first thing is the redshift of all the galaxies. Make sure that you say it's redshift of galaxies, not redshift of stars or something. Okay, so redshift of galaxies, that's your first bit of evidence. Your other bit of evidence is that cosmic background radiation. Okay, cosmic background radiation. Now, your cosmic background radiation is from these protons and neutrons here. Sorry, not the protons and neutrons. It's the matter annihilating with antimatter to form these photons. They were gamma to start with. However, what's happened is that over time, these have spread out. Okay, now they are evidence for the Big Bang theory, because no other theory can explain it. Now, they are everywhere, and they're in uniform intensity in all directions and in everywhere. Okay, now looking at the mark schemes in the past, things you need to know about cosmic background radiation is that the structure of them in ripples, that sort of adds more to the theory of the Big Bang. They were produced when matter and radiation decoupled. They were produced during this annihilation when we got matter and we got separate photons. Originally gamma radiation, as we've said, the gamma has redshifted to microwave. Originally it had higher energy, now it's been shifted down to microwave, which is a low energy electromagnetic wave. It's evidence that the universe began with Big Bang. Now the temperature we're at, 2.7 Kelvin. That is what would be predicted by the Big Bang model and predicted that these cosmic background radiations would be causing. Okay, so that's all the stuff that you need to know for the Big Bang. My other video on stars should give you a bit about how stars are formed and what happens in stars. I will be posting a video hopefully later on percentage uncertainties. Happy revision. I will see you tomorrow.